Good day, ma'am. We are the Group 3 and we will present our group's Laguna Salicylic Acid Manufacturing Plant for Plant Design 2. Dara, and I will present the product and project descriptions. This project aims to address the lack of manufacturing plant of salicylic acid in the Philippines as a raw material for analgesic drugs manufacturing, specifically for aspirin. This objective was encouraged by the emergence of COVID-19 pandemic, which consequently surged the demand for analgesics as a remedy for common COVID-19 symptoms. Our group conducted a feasibility study for Laguna Salicylic Acid Manufacturing Plant encompassing evaluation for labor, material, and utilities costs, profitability analysis, and other economic evaluation. LZMP will employ the Bayer process to manufacture a technical grade of 99.5% salicylic acid with a daily production of 23,451 kg by 2024. The proposed plant location is in Cabuyao, Laguna, which is a land area of approximately 21,500 square meters. The chemical structure of the product is presented by the figure on the left. The final product of the plant is solid and crystal form salicylic acid, since the target end users are manufacturers of aspirin. Aspirin is an analgesic which is used to reduce fever and moderate pains in the body.
Good day, my name is Bianca Belmonte and I will be discussing the process flow diagram. Shown in this slide is the overview of the whole manufacturing process. In concept, the study adopts the Bayer process to produce 99.5% by weight salicylic acid crystals. This is achieved by using a series of succeeding reactors for the carboxylation process, which include a fluidized bed with exact temperature control, batch reactor, and continuously stirred tank reactor. The said units are encircled in the diagram. With this method, salicylic acid for pharmaceutical use is manufactured from sodium salicylate at a shorter reaction time with less energy consumption compared to other existing processes. In detail, the process starts when solid phenol and 50% sodium hydroxide solution are separately fed into an agitated batch reactor operating at a temperature of 120 degrees Celsius and a pressure of 101 kilopascals. The resulting sodium phenoxide is passed through a dryer before it is sent to the kneading tank where it is granulated to 1 mm diameter particles. The dry granulated sodium phenoxide goes inside a fluidized bed reactor operating at 90 degrees Celsius and 550 kilopascals. Carbon dioxide is then sparged into the bed reactor to initiate the carboxylation process. Two outlet streams are then generated from the reactor. The first one carries the fluidization gas with sodium phenoxide to the centrifuge where it is extracted and sent to treatment, while the second stream carries the generated sodium salicylate to the CSTR. The carbon dioxide from the centrifuge is passed through a heat exchanger before it is sent back to the FBR to maintain the operating temperature of the reactor. In the last section, the amount of sodium salicylate from the FBR is enhanced by injecting liquid phenol to the CSTR that is operating at 160 degrees Celsius and 540 kilopascals. After that, the product is sent to the dissolving tank where it is dissolved in water. The resulting solution is then pumped to the crystallizer where it is reacted with sulfuric acid to form salicylic acid and its salts. Crystal orthosalicylic acid is finally obtained through filtration and the other byproducts are taken to treatment.
Moving on, I am Maria Teresa Adera and will present the summary of equipment cost and calculation. A tabulated summary of equipment cost is shown on the table. The total cost for the equipment is $2,846,523.12, which covers the cost for the 3 reactors, pumps, storage vessels, conveyors, filter, compressors, and heat exchangers. Here is a sample computation for equipment costing. The first reactor in the process is a stainless steel autoclave reactor with a capacity of 2,301.97 gallons. An online process cost estimator called Matches Process Equipment Cost Estimates was used to calculate the reference price in 2014. The specification for the autoclave reactor provided a cost of $241,300 in 2014. Year 2022 is the purchasing and installation period. Therefore, the purchase cost for that year was computed. The cost index in 2014 is 576.10, while it is 656.47 in 2022. The cost of the autoclave reactor in 2022 was computed by multiplying the cost in 2014 and the ratio of the cost indexes in 2022 and 2014. It was equal to $274,963.05.
I am Diane Angelo Bautista and will be discussing the study estimate of the capital investment, which is divided into two components, direct and indirect costs, considering the total purchased equipment cost is valued at $3.131 million using the provided fractions of delivered equipment under fluid processing plant. Firstly, it is important to note that we define the type of plant under consideration as fluid processing plant. The reason behind this is that from literature, as stated by Ray and Johnston, sometimes it can be quite tedious and difficult to categorize a plant, especially with multiple processes. However, based on the adopted process scheme of this design project, which is the modified Kolbe-Schmidt carboxylation reaction of Bayer, so that is Bayer process from patent literature, that is carbon dioxide sparging in a fluidized bed reactor. That is why the most appropriate type of plant is again fluid processing, as it refers to liquid or gas feedstock and intermediates. The only solid reactants take part in the preliminary processes, and most product for the preliminary and downstream lines are in liquid state. For this section, the calculations are quite straightforward since the fractions given are simply multiplied to the purchased equipment costs. For example, here we have installation under direct cost with a fraction of 0.47. So that is multiplied to the total purchase equipment, which is $3.131 million times 0.47, which gives us 1.471 million. The fixed capital is simply the sum of direct and indirect costs valued at 15.78 million, which is also known as capital expenditures. A short definition of it is that it is the depreciable amount invested in the early stages of the plant's construction. Next is the working capital, which is included in the total capital investment. It is the total amount to cover some operational costs. It has a fraction of 0.89, which gives us $2.79 million. Lastly, for the TCI, that is simply the sum of the two values prior. That is $15.78 million plus 2.79. That gives us $18.57 million.
I am Brother Kugan and I'll be discussing the annual cost and sales. Evidently, the annual total product cost can be determined using the formula given, containing the variable cost, operating rate, TPC depth, and inflation rate. For instance, at the year 2024, the first year production is expected to have an annual TPC of around negative $12 million. These are due to a variety of expenses such as labor, raw materials, manufacturing supplies, and general overhead. However, at the same time, the annual sales with similar variables with filled up is expected to have a return of around $14 million. Hence, the manufacturing plant expects to have a positive income over time.
Hello, my name is Shayna Kabanban and I am here to discuss the cash flow for our Laguna Salicylic Acid manufacturing plant. The year zero for the cash flow analysis is set to 2023. The money for the capital investment, which is the construction of the salicylic acid manufacturing plant, was distributed from 2021 to 2023 as shown in the table. the fixed capital investment or the FCI is calculated and adjusted to account for a 0.03 per year inflation rate. The cash flow values for the FCI, working capital, and total capital investment are all negative as presented in the table. This is because more money was required to be spent on the plant's construction as well as the purchase of materials and equipment during the specified time period. An inflation rate of 0.03 per year was also used to calculate the total capital investment and the product price inflation rate. Moving on, the annual gross profit values were calculated to determine the profit made by the manufacturing plant after deducting the cost of manufacturing and selling of our products. As shown, the manufacturing plant has a negative gross profit in its first year of operation, implying that sales are insufficient to cover the cost of manufacturing the goods or providing the services. However, it can be seen in the following year, 2005, that the annual gross profit calculated began to have a positive values. The annual operating cash flow follows the same pattern. Even though the manufacturing plant had a negative net income in the first year, the value calculated for the annual operating cash flow was positive. A positive cash flow simply means that the manufacturing plant made a loss during the specified period but also received enough cash to offset the loss. The positive cash flow also shows that the manufacturing plant's liquid assets are growing. As a result, it is also able to settle debts, reinvestments in its business, return money to shareholders, pay expenses, and provide a buffer against future financial difficulties. On this slide, it is presented the cumulative cash position demonstrating the effects of the salicylic acid manufacturing plant's cash flow over a 10-year plant life cycle. This graph depicts the amount of money invested and accumulated by the manufacturing plant at a specific point in time. According to the projection, there is a positive net cash flow coming in from salicylic acid production and sales starting from the end of year 2026. Because the projected cash flow is increasing over a 10-year period, it is safe to say that the manufacturing plant has a strong financial strength and will be able to return the invested money while also paying expenses and providing a buffer against future and financial challenges.
A profitability analysis was performed to assess the economic feasibility of this study. Three profitability metrics were considered, and these are the return of investment, payback period, and net return. The return of investment or ROI is a ratio between the net profit and total capital investment times N. The variable N refers to the projected plant life, which is equal to 10 for this evaluation. To measure profitability, its value is compared to the minimum acceptable rate of return, or MARR, which is set at 15% for this study. It is deemed desirable when the ROI is greater than the MARR, and based from the computation given in this slide, the resulting ROI is equal to 23.86%. Thus, it can be said that the project is feasible since the calculated ROI exceeds the MARR. Another metric used is the payback period. It defines how long it will take for the company to recover its initial investment. To establish the plant's profitability, the reference payback period calculated from the MARR is compared to the actual payback period from the annual operating cash flow. A project is considered desirable when the reference PBP is greater than the actual PBP. The equation for the two kinds of payback period is shown in the slide, wherein the actual PBP is equal to N times fixed capital investment over annual operating cash flow, while the reference PBP is equal to 0.85 over MARR plus 0.85 over N. It was calculated that the actual PBP is equal to 2.62 years, while the reference PBP is equal to 3.6 years. Since the reference PBP is greater than the computed PBP of the plant, the project is acceptable. The last metric is the net return. It is calculated by subtracting the expenses from the gross revenue. The proposed plant's profitability can be determined using the net income. A positive net return value indicates that the return meets the acceptable minimum rate of return, which is in this case is 12%. The equation for it is given in the slide, wherein TCI refers to the total capital investment. It was calculated that the net return amounts to $1.71 million, and since the computed net return is positive, the project is acceptable. In summary, the table presents the results gathered from the profitability analysis. It can be concluded that the project is feasible because the return of investment is greater than the MARR, the actual payback period is less than the reference payback period, and the net return is positive. All the values point to the fact that the proposed plan shows a promising and worthwhile investment that can compete in the Philippine market.
Overall, the study comprises the design project of the industrial salicylic acid processing plant located in Cabuyao, Laguna, Philippines. The manufacturing plant will focus on the production of salicylic acid, which is a major component of the composition of the aspirin drug. This can be used to treat different ailments such as fever, pain, and reduce the possible risk from the infection of the coronavirus. The production of salicylic acid will also utilize the Kolbe-Smith reaction, which was modified by the Bayer process. This includes the two-step carboxylation process at which two temperature shifts are required to yield a conversion of 90%. Moreover, a detailed planning and computation had led to the completion of the study. This includes the fundamental background, market appraisal, hazard study, economic analysis, and etc. The manufacturing plant is expected to begin its production by the year 2024. The expected value to be produced is around 23,000 kg per day of 99.5% weight of salicylic acid with an associated 15% market share. The capacity was solely based on the 329 operating days per year. The viability of the profitability analysis suggests the return of investment of $1.71 million after 3.25 years. Lastly, the break-even price is lower than the market value price, suggesting that it is an economically practical processing plant in the Philippines.